This is a 33 kilovolts substation whose only work is to cut the electricity when we are sleeping comfortably and then listen to our abuses. We will understand in detail why this happens, but there are senior substations which supply it. For example, this is a 132 kilovolts substation. Above this there are 220 kilovolts substations. Above this there are 400 kilovolts substations. Now above these also there is a 765 kilovolts substation, but we will talk only up to 400 kilovolts. You will understand its reason later. We understand in detail the journey from power generation to electricity reaching our homes. But our demand is only for 440 volts. So then a 400 kilovolts line in which about 4 lakh voltage flows. What is its purpose? We will understand with a practical example. There is a city in Rajasthan called Kota where a super thermal power plant is installed. Here electricity is produced from coal. This power plant is operated by the state government. There are a total of 7 generators installed here which together produce 1240 MW of power. We have shown only one generator to avoid complexity. Now this power has to be distributed throughout Rajasthan, for which, first of all, the power output of the generator is fed into a transformer. The name of this transformer is step-up transformer. Basically, the generator gives an output of 11,000 or 15,000 volts and it is stepped up to 4 lakh volts with the help of a transformer. Mostly step-up transformers are available only at the generating station. After this, there are all step-down transformers. The output of the transformer is sent to this switchyard. We will understand its working in detail later. But basically the work of the switchyard is that it gives multiple feeder output. Like here multiple towers are installed and all these towers carry power to different districts of Rajasthan. Now this is a 400 kilovolts line. Let us assume that electricity reaches Jaipur from Kota and the distance between Kota and Jaipur is about 250 kilometers. If we send the 11,000 volts coming out of the generator directly to Jaipur, then due to power loss, 11,000 volts will be reduced to 7 to 8,000 volts. Let me tell you one important thing. Do not get confused here. There is one thing called power. For example, the generator in Kota generated 1,240 megawatts of power, and this 1240 megawatts has so many watts that you can see on the screen. If we divide it by 1,000, then all these generators together are producing this many units of electricity. Now the target of the electricity company is that all these units reach our homes so that it can charge us for the electricity bill. But suppose by the time it reaches Jaipur, only 1 lakh units are left, then these 24,000 units above were lost on the way. Due to which the electricity companies suffer losses because we will not pay for this loss. We will pay for the units shown by the meter of our house. So to avoid this loss of power, the voltage is increased. Actually power is the product of voltage and current. So power is always fixed, but we can increase or decrease the voltage and current with the help of a transformer. So when we increase the voltage, the current decreases. Now when there is more current, the temperature of the conductor of the transmission line starts increasing and it starts heating up, due to which our power turns into heat energy and is lost on the way. So as soon as the transformer starts increasing the voltage, the current decreases in relation to it, due to which the temperature of the conductor will not increase much, and the most important thing is that when the current is less, we can make the low current flow through thin wires as well, which also reduces the cost of the transmission line. When this 400 kilovolts line reaches Jaipur, the process of gradually bringing down this voltage is started. This is the work of the switchyard. There are 3 incoming lines in this switchyard. Out of these 3 lines, 2 are coming from Kota and 1 is coming from Delhi. If the power plant of Kota fails, if we ever need more load, then we can use the power from Delhi as well. This transmission line terminates at this gantry tower. The first equipment of the switchyard is called lightning arrestor, and it is installed parallel to the transmission line. When lightning falls from the sky and starts coming down, you must have seen that it has many wings, and basically these wings keep searching for a tree or transmission line, which is at the highest height from the ground, because this lightning has to discharge itself by going inside the ground, and our transmission line is at a very high height. So, as soon as this lightning strike falls on the transmission line, 4 lakh voltage is already flowing in the transmission line, and due to this thunder lightning, this voltage starts flowing in cores, and we have designed the transmission line and all the equipment installed here according to 4 lakh voltage. Not according to cores of voltage. So the lightning arrestor sends the heavy voltage of this thunder strike directly to the ground, because at the time of lightning strike, LA provides a low resistive path and the current always tries to run straight, so it goes to the ground. Basically, a metal grid structure is set below the switchyard which easily grounds the high voltage. It also provides surge protection. Many times, the voltage suddenly increases in the line itself, and this is also grounded. After the first one, there is another device installed which is called capacitive voltage transformer. This device does 2 things. Use your mind a little and think, how will you measure this 4 lakh volts? Do we have any such device which can measure such voltage? Then CVT is a device which reduces this 4 lakh volts to 110 volts. which our normal meter can measure easily. We understand the other function of CVT with the help of wave trap. Transmission line transfers power. Along with this, it can also carry communication signals from one substation to another. But the thing to note is that when we make a call, the frequency of the signal in our mobile phone is in megawatts, due to which we can hear our voice clearly without any delay. But this power transmission line has a frequency of 30 to 500 kHz only, so the speed of communication becomes slow in it. Now this CVT works to inject and collect the communication signals of all the stations in the transmission line. But it is worth noting that it injects high-frequency signals in the line, and only 50 Hz frequency should reach our homes. So the wave trap installed here passes only the frequency of 50 Hz further. It blocks all other communication signals. Basically, it is installed in series with the line. Now from here the power goes to the current transformer. It basically measures the current of the line. So, whenever there is a fault in the line, the current of the line increases and it measures this fault current. We have explained the working of the current transformer in detail in this video. You can see it here. This transformer also reduces the high voltage coming from the line from 1 to 5 amperes, which our normal meter can measure easily. Now from here let's try to understand this complex switchyard, which is actually very simple. But the design of the switchyard can be slightly different at every place. But the equipment installed, they are installed in the same way and in the same order, like I have told you now and will tell you later. But one important thing, what are you waiting for? We are providing proper support. We will get the portfolio prepared anytime. We will explain all the ways of earning in detail. Now you have to extend your hand further. 3D animation is a great skill of today's time, and we have covered all types of animation from A to Z in the course of Advanced 3D Animation. You can create the animation you want. The complete detail is available in the description. There is nothing to wait for. Focus on learning something. Now let's come back to the topic. This 400 kilobytes substation has 3 buses. Main bus 1, main bus 2 and transfer bus. You will understand its use later. But our target is to charge these buses. The line from the city goes back near the gantry tower and the line is lowered from here. The first equipment that is installed as soon as the line comes down is called an isolator. It works just like the switch in our house. But we cannot turn off the high voltage line like the switch in our house. The line can be turned off with this isolator only when the line is already off. That means you can turn off the switch only when there is no light in your house. This is exactly how the isolator works. Immediately a question will come in your intelligent mind that what is this foolishness? But this is a very intelligent and sensible decision. When the line is on and we open this isolator, you will see that due to high voltage the contacts of the isolator are separated, but still the connection is maintained due to heavy sparking, and due to this heavy sparking the contacts of the isolator heat up and melt. So the isolator can never break the onload line. So let us understand how a line break happens. There is another current transformer fitted in front of the isolator. We had just talked about it. It also works to measure the fault current. There is a circuit breaker fitted in front of the current transformer. It is just like the MCB switch in our house. It gets switched off automatically whenever someone gets an electric shock. There is another isolator fitted in front of the circuit breaker, and from this isolator the supply is given to the main bus 1, due to which the main bus gets charged. Now let us take a fault condition which will make the whole concept clear to you. Let us assume that when the line goes ahead from the switchyard, a wire fell on the ground somewhere and a major line to ground fault occurred. So first of all, the current transformer installed here will check whether the current has increased too much. This means that there is a fault somewhere. This signal will be given to the circuit breaker, and the circuit breaker will trip the line due to this high current, due to which the supply of the entire line ahead will stop. Now the circuit breaker has switched off the line, but there is a big problem. This circuit breaker is called SF6 circuit breaker. And when it cuts the line, it has such contacts which go far apart. Now the way sparking happened in the isolator, the same kind of sparking happens here as well. But the SF6 gas present here extinguishes this sparking. But the problem is that when the circuit breaker breaks the line, the distance between its two contacts is very less. So it is possible that a little current can be felt inside the line. If understood in a more simple language, then the circuit breaker is just like a breakup between a couple. There is no communication between them, but the connection is still there. So for safety purpose, this isolator is also opened, which has ample distance between its contacts, which means that now the final breakup has happened. There is no contact left. By the way, we have explained the detailed working of the circuit breaker in this video. Do watch it, it will help you a lot in electrical engineering. Now one more question should come to your mind, that why is another isolator installed here? Actually, the mechanism of the circuit breaker is very complex, so it also needs maintenance. So to work on it, the isolator is also opened. In the same way, all the 3 incoming lines charge the main bus 1 in the same way. Now to charge main bus 2, the way isolator, whistle, circuit breaker, isolator are installed on main bus 1. In the same way main bus 2 is charged. In the same way, there is another bus installed here which is called transfer bus. So the line which is coming forward from this gantry tower, it is brought down and the transfer bus is charged with the isolator. Now circuit breaker and whistle are not installed in the transfer bus. I will tell you the reason for this later. But the thing to note is that all 3 buses are not charged together. Only main bus 1 is charged right now, so its isolator is in closed position. The isolator of main bus 2 and transfer bus has been kept open. Now this main bus is coming on this side. From where the line is brought back to the isolator and then to the circuit breaker, then back to the isolator and then back up through the gantry tower, this line reaches near the transformer. This is a step-down transformer which reduces 440 kV to 220 kV. In the same way, the connection of this second transformer is also installed here. Now this main bus is coming here as much as it is going to the other side. So multiple transformers can be installed on both sides. But here one more important device is installed. It is similar to a transformer, but there is no terminal in its output. Those who are from electrical engineering must tell in the comment box, what is the name of this device? We will discuss this in another video. Now I will explain the concept of bus to you in simple language. Let us assume that this transformer is giving supply to the place where government officials live in Jaipur, and this transformer is giving supply to the colony of people like you and me, Mansarovar colony. Now let us assume that the supply coming from Kota side is stopped due to some reason and the supply coming from Delhi is on, and it is not so efficient that supply can be given to both the side of government officials and Mansarovar colony. So it is a simple matter that the circuit breaker installed on the side of common people is first opened and our line is shut down and the air conditioners of the government officials keep running comfortably. Basically we abuse the electricity people, but they have these protocols that the supply of post area should not be shut down. Whatever the condition may be, and this protocol is also made by the government whom we vote for, and this is not a matter of Rajasthan. This happens all over India. Now let us understand the concept of these multiple buses. Like this line is coming from Kota and it is charging the main bus 1 in this way. But sometimes there can be a problem in the equipment of main bus 1 and maintenance work can be done on it as well. So in such a condition, the isolator and circuit breaker of main bus 1 are opened and main bus 2 is charged. Now if we move to the load side of main bus 2, then the supply is taken off on this isolator. From here, the line goes back up through the circuit breaker and isolator and is again fed to the transformer. So many times when substation maintenance work is going on, the load of one bus is transferred to the other so that our supply is not interrupted. Now this transfer bus has no security. Only one isolator is installed. Its work is only temporary. When some work is going on both the buses, then it is used only for some time. Then the load is sent back to both the lines. The main work of the switchyard is load balancing. When it is festival season, our electricity demand suddenly increases a lot. So in such a condition, all the lines coming from Kota and Delhi inside this substation are fed into main bus 1 and main bus 2. Now when both the buses are charged, some transformers are connected to the Kota line and some transformers are connected to the Delhi line, and in this way the load is balanced. Now, I have just told you in detail how these two main buses are connected. But still there is a bus coupler on the side which connects these two buses together, which is used many times at the time of load balancing. This is a step-down transformer which steps down 400 kV to 220 kV. You can see the working of the transformer from this video. But still this voltage is very high. Generally, this transformer will be given 220 kV supply in those areas of Jaipur where there is more demand for load. As far as man is concerned, this 220 kV substation is built in the area of government officials in Jaipur, and this transformer is sending supply to Mansarovar colony in Jaipur in the same way. In this way, some 220 kV feeders are sent to the big areas of Jaipur, such as at the Tehsil level. So multiple feeders come out from one substation which are sent to different areas. Now this 220 kV substation works just like a 400 kV substation. But when the power comes out of this substation, the transformer installed here reduces 220 kV to 132 kV. Now multiple feeders come out from this switchyard which then go to small colonies. As far as man is concerned, these feeders have reached colony A and colony B. Now the substation here reduces 132 kV to 33 kV, and many multiple feeders emerge from this substation. For example, let's say an industry has a demand for a lot of power. Then a 33 kV feeder is sent to the industry. Now when this power reaches there, another transformer is installed here which reduces 33 kV to 440 volts. We send one feeder to the railway substation. In the same way, One feeder is sent to the rural areas of Jaipur. So here also another 33 kV substation is made to balance the load, which reduces 33 kV to 11 kV. And from here multiple feeders of 11 kV emerge, which go to different areas of the village. And a transformer is installed in front of our street or corner, which reduces this 11 kV to 440 volts, and then supply is given to our homes from here. Now all these 33 kV stations also manage the load according to their own needs. Like in rural areas, people do more farming, so motors run there to extract water, so the demand for power is high. So all these stations can make 4 slots of 6 hours each, in which 3-phase supply is given to different areas of the village at different times, due to which the villagers run motors and do farming. So the final end consumers of electricity are us. Now all the substations here work in the same way. The bus is charged in every substation and then multiple feeders come out from it. But let me tell you one important thing. The journey of electricity that you saw was very long. But the generator installed at the super thermal power plant in Kota never stops. There are multiple units here, so even if one unit is shut down, the other is started. Here power is available anytime, still why does our supply go off? The reason behind this is load balancing. You have seen such a long journey of electricity, there is a lot of high voltage in it. Due to which sometimes due to heat any equipment gets damaged, or if any fault occurs then the line has to be shut down, due to which our supply is stopped. And as I gave you an example above, the supply is always on in post areas. So sometimes this is also a reason that when there is no sufficient load, then only the supply of the areas is kept on. And those who belong to the village must have seen that there are a lot of power cuts in the village because there are no factories in the village as compared to the cities, and due to the open environment people can stay for some time. I think you must have understood such a long journey of electricity very well. Still, if you have any doubt, then definitely write in the comment box. You can join the channel membership to support us. If you are interested in learning such animation